think we are back. We are back and we are alive. Let's make sure that our live pops up. Okay, it's up. It's great. Let's make sure. All right, perfect. All right, so I figure that it's good for us to refresh what we got stuck on yesterday, which was binary search. So I will also go back and do valid palindrome because I got stuck on that the other day as well, and I never came back to it. I did this shit in JavaScript. The fuck? Okay. All right. Should be cool. So we're gonna be going back through and reviewing these two that we did the previous couple days, but did not successfully solve. Okay, so I guess let's start with valid palindrome. So we have this reverse method, or reversed. So if s is equal to dot join reversed s, return true, else return false. See, this is kind of I guess cheating way to do it, but ta-da. Oops. Oh, right. And I have to do the remove of all the other stuff. Alright, but that's kind of cheating. Let's do it the way the problem intended. which is with 2 pointers. So let's go ahead and do that. So a phrase is a palindrome if, after converting all uppercase letters and lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backwards. And alphanumeric characters includes letters and numbers, right? So that means we first have to remove or turn S to lowercase. And then we also have to remove all non-alphanumeric characters. And then what we would do is have a left and right pointer. And while left pointer is less than right pointer, so yeah, so while we're iterating through, and we're gonna keep checking as long as left is equal to right. See, what's interesting here is it's an empty. Okay. Okay, so first let's deal with the case where it's an empty string. If L is equal to R, return if L is equal to R, return true. Okay, so that deals with that little edge case of a single character. If L is not equal to R, or sorry, if S at L is not equal to S at R, can we treat a string yeah. Yeah, so we can do that. Oops. So if they're not equal, then we're gonna know that it's false. It's not palindrome. But if it is, then we continue and we increment L. And decrement R, and this will continue until until left and right are not, or well, left is less than right. So if it never reaches this case, that means we break out of it and we need to return true. And the only time it will return false is if it is not actually a palindrome. So if any character in the string is not a lower is So that should remove all non-alphanumeric characters, and then we're going to create a left and right pointer here. So left should start at 0, or sorry, left and right should start at 0, and length of s minus 1. So you can honestly just uncomment all of this because I think that should be true. And instead of increment L and decrement R, we just do L plus equals 1 and R minus equals 1. So let's run this through case just to make sure this works. So we're going to have S here. We're going to make S dot lower. So now S is now just a mana plane a canal Panama, but in all lowercase. And then we're going to use this to remove all the non-alphanumeric characters. This would make it O of N, but I assume it would... Well, never mind. It would just do O of whatever S. Never mind. I'm tripping. Yeah, O of N, because it was going to have to iterate through the length of the string and only rejoin all the alphanumeric characters. So S is now S, which is now just this, right? And so we're gonna have a left and right pointer. And we're going to check if L is equal to R, we're returning true. And while L is less than R, which is true. If S at L is not equal to S at R, we're returning false. Otherwise, we increment 1. We go back to here while L is less than R. If S at L is not equal to S at R, return false. Come back. Mark A. Yep. Mark N. Yep. Shall go to the C, right? And so once we get here, L is now equal to R, which should break out of this while loop. And since if it's an odd number and both numbers are the same, it doesn't really matter what character, we just return true. That should work. Same thing here. S dot lower, remove all non-alphanumeric characters. It's going to be an empty string. L and R is equal to 0. And the length of S is 0 minus 1. If length of S is equal to 0, return true. Or length of S is equal to 1. So now we can just remove this case here. I like it better when we create variables all in the same place. So this should work now. So what I found was that with this blank character, we didn't deal with when it was 0. We only dealt with when length was 1. But yeah, this should work now. Because those are kind of like the edge cases where if it's 0 or 1, you can't really use the pointer. Because if the length is 0, or L is going to be 0, but then, or length of S is going to be 0 minus 1 is going to be negative 1, right? Which is not what we want. And then same thing with 1. I mean, it doesn't really matter. We can just kind of remove that. It's redundant because it's just going to go all the way to that and return true. Okay, I think I have a good solution here. Let's run it. See if... Ooh, hello. Unwork, unknown network error, try reloading page. Alright. What? Why did I get logged out? Okay, that's so weird. Okay. My code is back, but it looked like it wasn't for a sec, which is really confusing. Okay, so I think this should work. Let's try it. Okay. So it works for these two. Let's make sure that S is actually printing correctly. Oh, it actually is removing. Oh, I forgot to do that. Okay, sorry. Alright, perfect. I think this should work. Let's submit. Awesome. Nice. So we got a good solution here. I think we could, yeah. This is great. I don't know why I was so frustrated with it the last time, but I think also taking a look at the binary search kind of left and right pointers that they used was a little helpful. Having this be the base case is nice. Okay, cool. So we have done this. I'm happy with that. We can come to that, back to that later, another time, but for now, let's say we have completed that problem. Woohoo! Properties. Completed problems 7. Let's go. I can make this bigger actually. Make that a little bigger. Let's see. How big do I want it? I don't know. I don't like how big that is. Either want it bigger or smaller. I'll do it bigger to kind of cover up that whole top right corner. I think we have a lot of delay. It's all good though. Alright. Good job. Me. Back to binary search. Last night we got stuck because what we did was we didn't use a left and right pointer. We had a middle pointer. We had the kind of general idea, but not the correct implementation of it. We had the idea of putting a middle pointer, but we didn't really know how to move it between halves, you know, to get that log n runtime complexity. So, this time, I remember kind of the general idea of how to do it, based on the solution from yesterday. But given an integer array of nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, return its index, otherwise return -1. Alright, so the general idea here is that we are going to start in the middle, right? We're going to have a search range that is in between two pointers. So create left and pointer, right? And our search range, which is our search range, and then our middle pointer should be equal to I think it's left divided by right. I think. Oh wait, no. Holy. Right minus left divided by 2, right? So right minus left, so that'd be 5 minus 1 or 0 divided by 2, 2.5. 2.5. So if you did floor division, that'd be 2. So that'd be the left index. And then we do, I think, plus L, right? I think that looks right. Because once we're in the upper half, right, our search range is 5, 9, 12. Then we're going to have 5 minus 3 divided by 2. So that's 2 divided by 2, there's 1. Plus L, which is 3. So that's 4. Which would be 9. Good. Seems about right. I can fix that later if that's not right. And so while left is less than right, we're going to create this middle pointer, and we are going to check if target equals, let's just call this middle, it's probably easier. Target equals nums at middle. Target equals nums at middle, then return middle, else or okay, let's deal with the other. Okay, actually no, let's do this. If, else if, and then else. Kind of like that. So if nums at middle is less than target. So if our current middle is less than the target, then we know it's in the upper half, which means our new left is going to be middle plus 1, right? Because we're going to search from this range. So I'm going to do left equals middle plus 1. Else if nums at middle equal or is greater than target. So if, say our target was 0 here, then we're going to move right down to this bottom half. So that'd be middle minus 1. So we don't want to include this middle, so right is equal to middle minus 1. And then else target equals nums.middle, then we return middle. So if it gets to the case where we move L and R and they're now equal, then we can just return false. Or return -1. So this seems to be right. Let's double check to make sure that the logic works for 2, just to make sure the shift works correctly. So let's say that while left is equal to right, or while left, let's imagine that it doesn't exist, target's 2, and we're here. So while left is left and right, which is true, middle is going to be right minus left, so that's 2 minus 1 is 1, divided by 2, 0, plus 1 is 1. So if nums at middle is less than target, if it's less than target, L equals middle plus 1. So now left is here. Right, and now it doesn't. Okay, perfect. So that, I think this logic works. Let's create the left and right pointer. So L is equal to 0, and right is equal to length of nums minus 1. And so while left is less than right, we're going to create this middle, or it's fine, we can just keep the whole middle thing instead of M. But the rest of this logic should be correct. Let's run through this whole case just to make sure it works. So L is at -1, or L is at 0, R is at 5, and so while 0 is less than 5, we're going to have 5 minus 0, 2.5, floor division. Wait, sorry. Floor division is 2 plus left is 0, so our new middle is 2, so we're going to have 3. So if nums at 3 is less than the target, we're going to move the middle up to here. So now it's going to loop back around. While left is less than target, which is true, we're going to have 5 minus 3, which is 2. Floor division by 2 is 1, plus 3, which should be now 4. So middle is 4 now, and if nums is less than target, it's not, well, they're just going to return middle. So that meets our case. Let's do the case if it doesn't exist. So 5 minus 0 is 0, or 5, sorry. Floor division, that's 2.5, or 2. Plus 0, it's 2. And so our middle is here. And so if nums at middle is less than target, it's not. Else if nums at middle is greater than target, which it is, R is now middle minus 1. So now our middle is at 0. Or R is at 0. And our left is at oh, that's so weird. I hope this doesn't run anything. Sorry, I got kind of caught up. I don't know if this is actually right, but because if nums at middle is less or is greater than target, we're moving R to here because we know it is not this value. But I feel like we should include it, right? It would just be middle. So right is now just 3. I feel like that makes more sense. No. Let's just stick to our guns here because we don't need to include 3. We don't need to include 3 because we know that's not in it. So if it's in it, it will be in the next value or not at all. That's fine. So now our is -1, 0. And our middle is now 1 minus 0 divided by 4 division by 2 is 0 plus 0 is 0. So our middle is now -1. And if it's less than the target, which it is, L is equal to middle plus 1. So this should shift up to here. And now left is equal to right. And that should be returning -1 because it breaks out. Now L is equal to R. Perfect. Let's just run this. All right. Submit. I think this should be good. I messed up. Didn't deal with the base case or with the edge case where if length of nums. Let's see if there's any other cases. So no matter what, the length of nums is going to be at least 1. But for this to work, we need our left and right pointers to be at least, or the length of nums should be at least 2. So if it's equal to 1, you can just return if nums at 0 equal to target, return nums at 0, else return -1. So this is our edge case here. Everything else should be at least 2 or more. We're not going to have a case with 0. So I think that should be good. All right. Oh. Oops. Oh my gosh. If I make that mistake on an interview, it's... Dang. Definitely messed something up here. Okay. So I guess we need to check in the case where left and right are equal no matter what. So we can just do that at the end, right? Or God dang it. I messed up the logic somewhere. I thought I had it. Crap, man. Fuck. Alright. I'm gonna take a breather, see if I can recover from this for a sec. In a sec. Okay. Take a little breather. Let's come back. Let's solve this freaking problem, dude. So, the issue, I think, I don't know. Well, I feel like partially, maybe, the issue lies in my middle calculation. I don't think so. No. I think my middle calculation is right. But my cases for actually figuring out whether it's the correct item is right. So okay, we're back. So I think this is definitely right, because we're gonna start at 0, then to -1, right? And what we're going to do is we are going to keep this case while left is less than right. I really want to just find the solution. Look at the solution. Has it been 30 minutes? I don't know. I feel like I've started to get a general idea of it, but I don't know. I feel like I just messed up, bro. I did, but I'm not too far off. Oh gosh, how frustrating, man. Okay, wait. No. I think that should work, actually. Because here, let me take these test cases to make sure. Use test case and take this and use test case. So basically what happens is if it is a single item, right, it's going to start at 0 and we're going to have this length of nums, which is 1 minus 1, which is also 0. So L and R equal to each other, and we're just going to check. It doesn't matter which one. Doesn't matter which one, but we're just going to return L, which is going to be 0. On the other hand, if we have a case where it's 2, 5, right, L is going to be less than R, right? It's going to shift over so that now 5 is the target, and so middle is going to be on the left, so it's going to be 2, right? And so 2 is less than the target, so we're going to move L over here, and we're going to check if, so in any case, if we ever get to the point where L and R equal to each other, we just need to check if it's equal to the target and return it. Otherwise, return -1. I think it should work. Oh my gosh, please work. Please work. Oh my gosh. It was just a little minor tinker. Okay. I had the right idea. Oh, so freaking irritating. Alright, perfect. That's what giving yourself a break for a second does. So this is a log of n, time complexity. Pretty happy with that. We will take it off the list. You know what? We'll star these because we did have problems with them in the past. So if we ever come back to it later, we can review them. I think we're good on that because I solved that. Okay, awesome. We did 2 problems. Should I start on sliding window? Could. Maybe I do the daily instead. Let's see. It's a 78% medium. You know what, let's just take a look at it. So divide array into arrays with max difference. Oh, apparently. Oh, this is for yesterday. It hasn't changed yet. Alright, well, I guess. I don't know. New one should. Oh, it comes in 45 minutes, so that's fine. Well, I'm gonna shower probably then. Let me see. Let me take a look at this. 55%. Kind of forgot how to do sliding window, but hopefully it should refresh me. Yeah, I'm just gonna shower probably. Come back later, do the other one. I know it should be good. Alright. No one's watching, but if you are, you know, thanks for tuning in. I appreciate it. I will see you all in the next one. Thank you again. Bye-bye.